Hi everyone, here's another video. Sorry I can't be there with you once again, but it's not fair that just because a teacher can't make it, you are going to be behind in your learning and your understanding, especially compared to the other classes, right? And so here I am with another video. Please be good to the substitute. Please listen to them. Don't abuse the washroom system. And if you have any questions, please, by all means, reach out. Also, I want to encourage you to continue taking these videos seriously. Just because I am not there doesn't mean you should slack. In fact, if anything, this course, this credit, the success, the knowledge, the understanding, they are yours to take. It is not necessarily mine to give. So regardless of what I do, it shouldn't stop you from getting to where you want to be, no matter how bad or good of a teacher I am, right? So let's take this seriously. Today, I have a lesson on negative and zero exponents. So this might be a new thing for some of you, or in fact, most of you, because I'm not sure how much of this might be covered in elementary or middle school. So there are two things, and it's a very short lesson, but it involves some patterning and some understanding, some wrapping heads around, I guess, some abstract ideas. Ready? There's two things we're going to do. We're going to talk about zero exponents, and we're also talking about negative exponents. If you have, in a nutshell, this is the too long, didn't read version, okay? If you have a zero exponent, so any base to the power of zero, it's always going to equal one, guaranteed. So you can give me like negative 5,000 to the power of zero, it's going to equal one. You can give me 99999 to the power of zero, it's going to equal one, always. Okay, that's the first lesson. Second lesson, if you're dealing with a negative exponent, you are going to be getting rid of the negative by turning it into a positive. But as a result, the base is turned into its reciprocal. So for example, if I have 2, all that, to the power of negative 5, this is going to turn into a positive 5, but the 2 is going to be rewritten as a reciprocal. And that is why we say, 1 to the power of 5 and 2 to the power of 5. But of course, 1 to the power of 5 is going to be 1. So it's going to be 2 to the power of 5. Okay. Another one, let's say I have 2 over 7 to the power of negative 2. I can rewrite this as a positive 2 with 7 over 2 instead. And I'll try to explain why. Okay. So you can listen, you can take notes of what I'm going to do next, or you can write it down somewhere on a blank piece of paper, whatever. Okay. But here it is. This is why we have zero and negative exponents equaling the what way they do. If I was there in person, I would pick on someone and ask them to help me out with some of these answers. But since I'm not, just do it in your head. 2 to the power of 1. What is it? 2 to the power of 2. What is it? 2 to the power of 3. What is it? And 2 to the power of 4. What is it? The answers? 2, 4, 8, and 16. Right? This is 2 times 2. So maybe I'll write that down. 2 times 2. This is 2 times 2 times 2. And this is 2 times 2 times 2 times 2. So visually speaking, what is happening every time I increase in the exponent? As my exponent gets larger by 1, what happens to the values? Well, I'm multiplying by an extra 2. I hope everyone sees that pattern. Once again, if the exponent grows by 1, well, I'm multiplying 2 one more time. And this is where I ask you to use a bit of your imagination. Instead of going up by 1, I'm going to ask you to pretend we're going down by 1 in the exponent. If I went down by 1 in exponent, what am I doing to go from the top row to the second row? What am I doing to go from the second row to the third and the third to the fourth? I think you get the point. If I go down in an exponent, I'm essentially dividing by a 2. Does that sort of make sense as a pattern, right? 16 divided by 2 is 8, and 8 divided by 2 is 4, and 4 divided by 2 is 2. And here is the final kicker. If I go down by another exponent, what would that equal to? Well, assuming the patterns don't change, 2 is going to be divided by another 2, giving me a 1. That is why anything to the base of 0 is a 1. I could do anything. I could do 100 to the power of 4, 100 to the power of 3, 100 to the power of 2, 100 to the power of 1, which is 100. But when I bring it down a notch, 100 to the power of 0, I take that and I divide by the same number we've been working with until now, which is going to be a 1. It's always going to equal a 1. For me to continue on with negative exponents, you are going to have to believe me that this is not just some hocus pocus, that there is a logical explanation that 2 to the power of 0 is 1. Why? Well, what if I ask you to continue to divide? 1 is going to be divided by a 2. What does that equal to? Well, 0.5, but let's keep it as a fraction. It's going to be 1, literally, divided by 2. Yeah. And what if I go lower? 2 to the power of negative 2. Well, that means this half is, again, going to be divided by a 2. Well, what is division of 2? Half of a half. Well, if you don't believe me, if you're starting to get confused, know that this is 0.5. 0.5 divided by 2 is 0.25, right? But because you've practiced your fraction divisions, let's do it. Half divided by 2 is the same as half multiplied by 1 over 2, which is going to be 1 over 4. Okay. And then I'll do it one more time just so you believe me. 2 to the power of negative 3 is going to be division of 2. So that's going to be 0.125, which might not mean much to you. And this is why we need fractions. 1 over 4 divided by 2 is the same as 1 over 4 multiplied by half, which is 1 over 8. This is 1 over 8. And so I'm like, see, look at, it's my proof. At this point, you'd be like, wait, hold up. What are you talking about? You didn't prove anything. How do I know it's supposed to be some reciprocal? How do I know 2 to the power of 3 is supposed to be 2 to the power of a positive 3 like that? Okay, or even better, like positive 3 like that. Like, where does that come from? Well, I'm going to ask you to take a look at all of these numbers that we wrote over here. The fractions, not the decimals. 1 over 2 is just 1 over 2. But 1 over 4, what is 4 as a power? 4 as a power is 2 to the power of 2. What is 8 as a power? 8 as a power is 2 to the power of 3. And what is 16 as a power? 16 as a power is 2 to the power of 4. And so anytime you have a negative exponent, it's essentially the same as putting it as a reciprocal with a positive exponent instead. So by that pattern, the rule is anytime anything has a power of 0 or exponent of 0, the answer is 1. Anytime it's written as a negative, we can rewrite it as a positive. Let's practice that. Okay, so evaluate the following. Anytime you get a question that has an exponent of 0, just like raise your hands up, be like, thank you, Mr. Kim. This is a 1. Done. You're done. Nothing more, just done. Here is a division with the same base, which means it's 12 minus 12, which is w to the power of 0, which is 1. Done. Oh, here we have a power of a power. 3 to the power of 0 times 4, which is going to be 3 to the power of 0, which is just 1. And you're done. I'm going to ask the substitute to pause if the students need it, but I am going to move on, going once, going twice. Next, if you have a negative exponent, let's get some practice. I'm going to actually write it in 2 different ways in case some of you might get confused. 5 to the power of negative 3 can be written as 1 over 5 to the power of positive 3, which in turn will turn into 1 to the power of 3, which I don't have to write, over 5 to the power of 3. Is 1 times 1 times 1, 5 times 5 times 5. This one, as this is my base, I can rewrite the entire base to the power of a positive by writing this as a reciprocal. That's it. You're done. Next, we have this one, again, negative 3 to the power of negative 4. So that only the 3 is affected by the negative 4. So this will become negative 1 over 3 to the positive 4. That's it. We're done. And yes, you can use a calculator to solve this, right? But it didn't ask for that, so we don't have to. And so take a look. Oh, one last example that might be worth your time. It can also apply to fractions such as this. And here's a quick explanation. 2 to the power of 3 to the negative 3 means this is 1 over 2 to the power of 3 to the negative 3, which ends up becoming that. So if you want to pay special attention, this becomes that. And you can solve it very easily without any confusions of having a negative exponent. Okay? That is the end of our lesson. It is your responsibility to be able to distinguish 0 and negative exponents and answer them accordingly. The question will typically say, never leave in negative exponents. It will always want a positive exponent. So looking down, here's some examples. Rewrite each expression as an equivalent expression with a positive exponent, just like that. I'll do some very quickly. And the teacher can leave this on the board. 1 over 10 to the power of negative 3 could be 10 over 1 to the power of positive 3, which of course is just 10 to the power of 3. And if the question asks you to solve it, it would be 1,000. This is going to be 11 over 3 to the positive 1, which is just 11 over 3. Here, the reciprocal is only applied to the base, which if I had to solve it, what would that be? 1555 is 125, and 6 times 6 times 6 is 216. Something like that. Okay. So the rest of class time, please. My expectation is that you do finish this. I am planning to give you a kind of entry or an exit card or something to see how far or how hard you've been working while I was gone. Please take this seriously. I would actually be very disappointed if you did not progress in your exponent knowledge just because I was not there. Let's get it. See you when I see you, and work hard.